Here you can see the clamp meter is hooked up to our main charge wire coming right off the back of the alternator. So this measurement is going to be every bit of amperage that is being required of the alternator. And you can see our result is nothing short of astonishing. We're sitting at 95.5 amps, and this is at idle. Hey guys, what's going on? I'm Jimmy, and this is One Road. I recently made a video called Why You Should Never Ever Install Electric Fans. When I would sit at a stoplight, I could see my voltmeter going all the way down into the red zone, which tells me that it was not producing enough amperage to run these fans when it was hot. So what did I do? Well, of course, I stepped up my alternator amperage and I thought, okay, well, let's take 105 and let's add 30, that's 135. Let's go for a 140 amp alternator. I have to say, I made a mistake there. 140 amps still wasn't enough. I was blowing fuses and it just wasn't enough to keep up because, again, alternators most likely are not rated for hot idle. I'll link it below. The purpose of that video was to highlight some of the issues and facts that I learned from my installation. The biggest issue I've been facing, and what I tried to highlight in that video, was the need for adequate power production from your alternator. The alternator I have is certainly not up to the task. I'm gonna go ahead and give it some cranks here, some RPMs. It's a good alternator, don't get me wrong, but it just doesn't produce the amperage needed at hot idle to keep up with the demand. Now, let me explain. When you see an alternator's rating at, say, 105 amps or 140 or 160, those ratings are the maximum amperage that an alternator will produce at cruising RPMs. Cruising RPM, let's say at like 1800 or 2000. The number that's not given is the amperage production at hot idle. By hot idle, I'm talking about everything is up to operating temperature, it's a hot day out, and you're sitting at a stoplight in drive. That number could be half, like say 50 amps. My 140 amp alternator at hot idle was producing like 60 amps or so. Now, when would this matter? Well, let's say it's the middle of summer, you're in Las Vegas and it's 115 degrees outside. And you have a nice set of electric fans under the hood that are gonna keep everything cool. But they pull roughly 30 amps, sometimes more. On top of that, let's say you have the AC going front and rear. That's 2 blower motors, 2 electric fans, and everything else that's needed to keep the truck running. Let's say your total amperage requirement is roughly 90 amps, maybe even 95. Now, if I pull up to a stoplight and sit there for 5 minutes, my alternator is producing 60 amps. But the requirement is 90. It doesn't take long to realize this is a recipe for disaster. The default has to come from the battery, which it cannot produce. The battery voltage drops, and when that happens, the amperage requirement increases, as does the heat. Every component in your car gets bogged down due to reduced power. The dual electric fans spin slower, the AC blower motors spin slower, the idle gets rough, and fuses start popping. That is precisely what was happening to me. But today we're gonna change all of that. Today I'm installing the bee's knees of alternators. This alternator is by a company called Mechman, and it's called their 250 amp Elite series. This particular alternator was tested before it was shipped out, and it shows that it puts out 198 amps at idle and 256 amps at cruising speed. 198 amps at idle is way more than I need, but that's good. That means that I should be running at 50% capacity at all times, which should prolong the life of this alternator. So let's install it. The first thing we need to do is remove the old alternator, and we'll start by disconnecting the battery. Then we'll loosen the tensioner and remove the belt. Now we can simply remove our factory wiring harness, disconnect the positive charge wire from the back, unbolt the 3 bolts, and remove. And with everything out of the way, we can test fit our new alternator. Well, it fits pretty good, but there is a rear mounting tab for the old style alternator that'll have to be cut off. Our new alternator is a little bit too big to leave that on, and it doesn't use it anyway. So I'll grab my grinder and cut it off. File the rough edges, spray some paint, and you're done. No one would ever know. Now that the tab is gone, I can recheck fitment. And it fits. but the holes don't line up exactly. If I first install the main through bolt, the one that goes through the whole alternator and threads into the mounting bracket, we can see that the other bolt hole comes close but doesn't quite line up. Now, Mechman does know about this issue, of course, and so they include a thinner bolt. This bolt is supposed to be able to fit through the remaining space. However, in my case, it's not quite fitting. So I'm going to take a file and start reaming out that hole. After a few minutes, I can check my work. And what do you know? She fits. Now we can work on the main charge cable. Mechman specifically states that the lug going onto that main charge post must fit that post precisely. If it's too big and there's too much slop, we may get a bad connection which could cause the end lug to melt or start a fire. We don't want that. Because of this issue, Mechman has included the lug required. So I'm going to cut off my current lug and crimp on the lug Mechman provided. Now, my 2-gauge wire is a little too small with this provided lug, but not to worry. That hammer crimper will combine them both into one solid piece. With the charge cable done, we can move on to our wiring harness. The new Alt uses a different wiring harness, and so Mechman has included an adapter. Now, interestingly, one side of this adapter is 3D printed. So I called Mechman just to make sure that this was all kosher, and they reassured me it was. So I connected it up, and there is one loose wire that is left. This loose wire is for a switched 12-volt source. Again, talking to Mechman, they told me that the one wire coming from my original factory harness possibly wouldn't be enough to tell the alternator to turn on. And because of that and a battery light that will turn on in the dash, I need to hook up this wire to a 12-volt switch source. And I found mine in the fuse panel under the hood. I did, however, start the truck without this wire hooked up, and it seemed like everything was working just fine. I measured 15.1 volts at the battery, which means that the alternator was working. But I did get that red battery light in the dash, so it looks like we do have to hook up this blue wire. Okay, let's recap. We cut off the stock alternator rear mounting tab. We reamed out one ill-fitting mounting hole. We changed the lug on our charge wire, hooked up our harness adapter and 12-volt switched wire, and tightened everything down, including the alternator, the wiring harness, and any other loose wiring. I do want to mention here that I'm running number 2 or 2-gauge welding wire that is pure copper. In my initial discussion with Mechman, they told me that 1/0 cable was recommended. But after talking to them a second time, we came to the conclusion that my 2-gauge will work just fine with the distance between the alternator and the battery. Now, let's take her out and see how she does. Well, it is now the day after the install of the Mechman 250 Elite in my 1995 Suburban, and we're gonna do a cold start. All right, so what I want you to pay attention to here is this voltmeter over here. Here we go. Look at that. All the way up to, say, 14.5 or so, right up over the 14. Now, I haven't seen that in this truck ever since I started driving it. That is a really good sign with this brand new alternator. Talking to the guys at Mechman, they said upon a cold start, I should see in the high 14s to even 15.1 on the voltmeter. I believe once it's fully warmed up, the charge voltage would be about 14.5. But right off the bat, this is a great start. All right, so I've been driving around quite a bit trying to get my motor up to operating temperature, and it looks like I just reached that point. Now, if you notice, I'm in drive, I've got my foot on the brake, so my tail lights are lit up, and I don't know if you can hear it, but my dual electric fans are running also. And the voltmeter is still right up there at the 14 volt point. Now, I do know that this voltmeter isn't quite accurate. When I take a reading at the battery versus what the voltmeter is reading, I get a different result. I would say the voltmeter here is probably a good half to a full volt low. But when we're talking about comparing my in-car voltmeter to what it used to be with my old alternator, this is leaps and bounds better. I'm gonna go ahead and turn on the air conditioner. I'll also go ahead and crank on the rear AC, and you can see the voltmeter is still right up there at 14. and I'm in drive and my RPMs are very low, probably 600 to 650 RPMs. This is very, very promising. So what this means right now is I have both my front and rear AC blower motors going. Of course, my dual electric fans are turning. I'm in drive with my foot on the brake, creating another load from the bulbs back there, and my RPMs are only about 600. You can see my voltmeter is doing just fine. Even if I crank my fans all the way up and crank this one all the way up, everything is on full blast now, and you can see my voltmeter is still sitting right up there at the 14, not even budging. Now I'll go ahead and turn my AC down just so you can hear me. This is awesome, guys. Before, with my old alternator, if I were to sit here, like say at a stoplight, in drive with my foot on the brake, my voltmeter would steadily just start creeping right down into the red zone. Like I said, the voltmeter is probably wrong. Still though, it's creeping all the way down into the red zone, showing that the voltage is dropping fast. That, of course, is with the air conditioning on both front and rear. And the problem is, obviously, the RPMs of my motor were too low to run my old alternator. The alternator just wasn't up to the task to provide the amperage needed by my truck in these situations. Now, one thing's for sure, this truck pulls a lot of amps. With both internal blower motors on high, my dual electric fans running, and my foot on the brake with the rear incandescent bulbs pulling some amperage, and the headlights on, this thing is probably pulling about 100 amps. And sitting here in drive at idle 600 RPMs, this alternator is able to handle that no problem. I'm really, really impressed. All right, so you can hear my fans running. Here we get a peek at the Mechman 250 amp Elite alternator. And there you can see my 15-inch dual electric fans that are both running pretty fast. In terms of temperature, it's obviously hot, it's running, but I can touch it for a few seconds here and there. It's not boiling hot. This blue wire you see here is the 12-volt switched power. I have it temporarily running into this fuse box here. You can see I did run my alternator case ground straight to the negative post on the battery. I'm gonna get a cover for this also. And there the fans just kicked on, and boy, do those things pump some air. This is what it sounds like up front. Very, very strong fans. Well, we saw that everything seems to be working amazingly in a practical application. But let's check the numbers. You can see I have my leads hooked up to the battery, everything is off, and the battery is reading 12.77 volts. Let's go ahead and start it up. I just started the truck and you can see that it's charging at 14.94 volts. This is exactly what Mechman said I should expect. Now let's turn on every accessory on the truck, including the headlights, and see how much the voltage drops. I now have both the front and rear air conditioners on full blast, which also turns on my dual electric fans under the hood. The headlights are on and the radio. And you can see we're sitting at 14.65 volts. This is very good. Let's now measure the amperage. We'll switch to the amp meter, and I'll use this select button to switch from AC to DC. Then I'll zero it out and hook it up to our main charge wire. Here you can see the clamp meter is hooked up to our main charge wire coming right off the back of the alternator. So this measurement is going to be every bit of amperage that is being required of the alternator. And you can see our result is nothing short of astonishing. We're sitting at 95.5 amps, and this is at idle. Now, a good way to measure whether this is everything being required of the alternator or not is to give it some revs. If these amps go up a lot when I give it some revs, then you know that the alternator is not able to keep up at idle, but is able to keep up with more revolutions. So let's try that out. And you can see that even with some RPMs, everything stayed solid. There was a very minute adjustment, but that's just due to the higher RPMs and the alternator having to adjust. Well, there you have it, guys. I have finally fixed the problem that has been plaguing my truck ever since I installed my electric fans. Now, I knew this was the problem all along, but because of the cost of these alternators, I held off as long as I could. Finally, I bit the bullet and bought the alternator. And I'm glad I did, because this is the best alternator on the market. Now, I don't have to worry whether I'm in traffic or on the side of a mountain somewhere. I'm gonna have plenty of juice to go around in this truck. Well guys, I hope you enjoyed this video. I hope you got something out of it. And if you did, I hope you'd hit that thumbs up for me. Also, don't forget to subscribe if you're not already a subscriber. Please check the description below for more information and links to anything you've seen in this video. I'm Jimmy, this is One Road, and I will see you in the next one. Well, babe, do you like it?
Yeah, babe. Looks shiny.
So does that mean you approve?
I approve.